Overview of classification. We're going to look at some of the basic concepts for classification, and we'll go into more depth with decision tree induction, Bayes classification methods, and then talk about the evaluation and techniques for improving classification accuracy. So there's classification and there's prediction. And classification is when we're talking about categorical data. So when we have class labels that are discrete or nominal type values. Did they buy a computer or not? That would be a binary. It's discrete. It's got two different options and it's non-numerical. We could be predicting a category for a major or interest or such like that, nominal values. For prediction, it's on continuous valued functions. So we're trying to predict some missing values, or like the stock market, what would the price be? So we're following the same techniques, it's just there's sometimes a variation on what we do with category data versus a numerical data. So what we're doing with this classification, we are trying to construct a model that will help us classify new data based on some training data that we have. So we already have training data, a lot of data that we can use that already has the classification in there for us, so we can build a model. So for example, if we were working with fraud or not, and we have a bunch of data that has transactions that are not fraud as well as ones that are fraud, we can use those transactions of customer, time, location, the amounts, and the historical data to make a decision on new transactions and whether they're fraud or not. So many classification problems can be binary, like a yes or no type answer. And sometimes you'll have multi-class scenarios as well. So the process for creating our model, step one is to do the learning. We want to take our data set and we want to separate a training set and a test set. So we want some of the data that we have to be able to use and pretend like it's new data coming in, run the model on it, and then determine how accurate our model actually is with this other test set. So we tend to separate out the training data from a test data set, all from the data that we have. And we build out the model using our classification algorithms. And typically, our model might be constructed on 80% of the training, and then 20% we save for that test. And if it performs well on that 20%, then we have a pretty higher confidence that our model is going to work on the future unknown cases. And so here's some example with name and rank, years, and tenured. We go through the build out a model. We have some rule here. If the rank is professor or year is greater than 6, then we're going to need to classify as tenured is equal to yes. So step 2, we go through and classify. And so we're going to use the test set, usually it's 20% to verify if it's good, and calculate some accuracy metrics based on our model. So we have the testing set, we set up our classifier rules, and we're going to take this unseen data that our model did not see, and that's our test set, and we're going to run our test set through the model and calculate how accurate it was. So we have two terms, supervised versus unsupervised learning. And supervised, what we mean by that is we have some knowledge. So we have the class labels in our data set. And that's a classification data mining technique that we're working with then. So the training data, the observations, the measurements, we have the class label that we want to classify to. And so our new data that comes in, we were trying to classify to one of those classes that we have. So the unsupervised learning, an example of this would be clustering. This is where we don't have predefined clusters or classes. There's no class labels even in the training data set. And so what we're trying to do is establish the existence of these classes or clusters, and we may or may not have any kind of label for it. So one example would be like on Amazon, you're trying to find customers that are similar so you can recommend other books or products that they might also be interested in. We don't have a label for those types of people that like sci-fi and sports and VR and such. we don't have labels for all of that. We just need to group them together and form those clusters. So that's unsupervised learning, where we don't have a class label that we're working with. We're trying to group them together. And we use distance function to identify in our calculations. So supervised, we have prior knowledge of the classes, who wants to buy a computer, for example, or who actually bought the computer, and their other attributes of income and student or not, and age and such. For clustering, we don't have any class labels, so we're just looking for a good match. So with our classification, it's a two-step process. You build the model and then you check and test it with your test set and look for the accuracy. So model construction, we have class labels, we divide up the training set, and we build out the model. And we're going to look at different models, for example, decision tree or the Bayesian classification, naive Bayes classification. Accuracy, then, we run the test set and we figure out how many were correct, what's percent that were correct, and we'll talk about some other metrics as well. And if the accuracy is good, then that model might be good for new data that comes in.